Today's video is about the different types of chemical reactions. There are going to be 5 different types where I'm going to give you a chemical formula or chemical reaction, and you're going to have to be able to tell me, based on what we go over today, what type of chemical reaction that is. We're going to do tons of practice with this. This is typically the easiest thing for this unit. Also, we will do a lab and demonstrations as well. So the first type of reaction is combustion. Combustion reaction, some key words that you need to make sure you understand, is the burning of a hydrocarbon, which is typically just a CH compound with whatever subscripts you want to put there. So CH4 would be an example of a hydrocarbon. It's called a hydrocarbon because it contains a hydrogen and a carbon. And the hydrocarbon reacts with oxygen gas. When this happens, it always produces carbon dioxide and water. So this is the basic setup of a combustion reaction. You have a CH compound plus O2, and it will always produce carbon dioxide and H2O. So identify a combustion reaction, you pretty much look at the beginning piece, CH plus O. Next, decomposition. To decompose means to break down. The decomp piece, decompose, decomposition, all of that means to break down. So you're going to start off with one compound, one reactant, and it's going to break into 2 single elements. So for example, H2O2, when it breaks down, it forms H2O plus O2. So you're taking one compound and breaking it apart. The key thing there is that one reactant. And this is just an illustration of what actually happens. So red and blue go together and then they separate. Then you have the opposite of decomposition, which is the synthesis reaction, which means to combine. So synthesis and combination mean the same thing. So synthesis means the combination of 2 or more substances form a compound. So the key thing you're going to look for is one product. It's going to form one compound. So you take 2 single things and you form one compound. So for example, magnesium plus oxygen, when you burn magnesium, which when you burn something it reacts with oxygen gas, it's going to form MgO. So you're taking 2 things and forming one compound. Single replacement means literally one thing is being replaced. So one element replaces another. So this, I like to use the analogy of going to like prom or something like that. You're dancing, so this is you and your date. And then somebody is trying to come in and take your date away from you. Okay, so you have a couple dancing, somebody comes in, splits that couple up, and you form a new single person and a new couple. The metal always replaces the metal, non-metal always replaces a non-metal. So this is just talking about the single element here. If it's a metal, it's going to try and replace the metal. If it's a non-metal, it's going to try and replace the non-metal. So to give you a visual, okay, so A is coming in, knocking out B, so then you get B plus AC. And then here is just again showing you a picture of visually what it would look like. Then you have double replacement, which means 2 things are getting a new partner. So this is like do-si-doing or something like that, where, or let's say you do a double blind date, and somewhere in the middle of the double blind date you realize that y'all should be with the different people. So A and B start off together, C and D start off together, and then they simply end up switching the D and the B. So you get AD plus CB. So you start off with 2 compounds on the left, and you have 2 compounds on the right. Now, key thing for chemical reactions is you have to be able to tell when a chemical reaction occurs or not. So some key things that you're going to look for is the following. The main stuff is in yellow: a color change, production of gas, precipitate forms, change in heat or temperature. But you're not going to know if this happens unless you actually see something occurring. So for a color change, it has to be dramatic. It's not going from a dark blue to a light blue or anything like that. It's going to go dramatically from blue to red or something like that. This does not include dying or fading of material. Production of gas, how do you know that your soda has gas in it? Because it bubbles. Okay? Anytime something is bubbling, that means there's some sort of gas being formed. Precipitate forms. This means a solid forms from mixing two liquids. Now this, for whatever reason, students get this one all kinds of confused. Precipitate forms means mixing of two liquids. This does not mean that you've taken it and put it in the freezer and it turns into a solid. I mean, it literally will turn into a solid right in front of your eyes without any change in heat. Then the last one, change in heat and temperature, does it on its own. Again, I didn't mean to cross that out. That's me underlining. This means it does it on its own. There's no heat source. So literally the temperature changes when you mix two things together. Okay? And you will feel the heat change. Now, the next few slides are splint tests. So when you have a fire, and I'm going to do these in class, so you'll get a sample of what happens here. When you do a splint test, it means you're taking some sort of wood stick and putting it into whatever gas has been formed and figuring out what gas has been there. So for oxygen gas, to tell if you have oxygen gas or not, you light a wooden splint, blow out the flame, but make sure that the tip of the splint has a reddish glowing tip. That sort of orange, you can tell it's super hot, but it's not really bursting out in flames piece. And then insert the glowing splint into the mouth of the test tube. And this is the key thing you've got to know here. What happens? If you have oxygen gas, the glowing splint will catch fire again. Okay, this is why it's bad to have a fire at a hospital, because of all the oxygen tanks. If fire gets anywhere near oxygen, it's going to explode. So that's what's happened. Oxygen supports burning of fuel. Since the wooden splint is form of fuel and the tip is red hot, it will begin to burn in the presence of oxygen. Hydrogen gas. Again, you take a wooden splint. Do not blow out the flame this time. Insert the wooden splint into the mouth of the test tube. This is what happens. You will hear a slight pop sound. Now, sometimes it's hard to hear, so the one I actually do in class you might not hear either. But it's very, very soft pop noise. Sort of sounds like a yipping kind of dog. The test works because hydrogen tends to mix slightly with oxygen. That's where we get our water vapor and things like that. Since this creates explosive mixture, burning the splint will ignite hydrogen gas and tiny explosion occurs. Now, carbon dioxide. If you know anything about a fire extinguisher, it contains carbon dioxide. And what does a fire extinguisher do? It puts out the fire. So if you have carbon dioxide being formed, you're going to take the wooden splint, and it's on fire, you're not blowing it out. Insert the burning splint into the mouth, and the flame is extinguished. Carbon dioxide is neither explosive, and it does not support combustion. And then the last test, lime water test. This does not mean that you took some lime and put it into water. It's a chemical mixture, okay? If lime water solution turns a milky white, the gas is carbon dioxide. The test works because lime water and carbon dioxide react to form a white precipitate. So if lime water turns milky, that means you have carbon dioxide. Now again, I will pretty much do demos that cover all of this information again in class. And we're going to do tons of practice with this as well. This should be extremely easy. If you have any questions, you need to let me know.